Okay, so today's lesson is topic 8, reaction rate, and this is the last topic of this unit. All right, so reaction rates. So we've talked about chemical reactions quite a bit, and we've looked at chemical equations as well. But last thing we have to talk about is that chemical reactions, they can occur at different speeds, and that is what we are saying as its reaction rate. So it's a measure of how fast a reaction occurs. All right, so we can measure how quickly one of the reactants is disappearing. You can measure how quickly one of the products is appearing, or how the amount of a substance changes per unit of time. So those are some ways of measuring reaction rate. How can we change the rate of a chemical reaction? So there's a few ways we can change the rate of a chemical reaction. The first is temperature, by changing temperature. So by increasing temperature, that will increase the rate of most chemical reactions because particles are moving faster, they're colliding with each other more frequently, so therefore the reaction will occur at an increased rate. For example, baking a cake to change the liquid batter into a cake. Another example, keeping fruit in a fridge to slow down chemical reactions. All right, so here decreasing the temperature to slow down the chemical reaction, right? Increasing the temperature to increase the rate of chemical reactions. Another method to increase the rate would be stirring. So stirring or mixing or shaking will speed up the reaction rate. Another method would be to change the size of the reactants, therefore giving it more surface area. So instead of having a giant block of something, you can cut it up into smaller pieces. That will give it more surface area. Therefore, the reaction will take place quicker. Another method would be to change the concentration of the reactants. So basically increasing the number of particles of substance per unit volume. That will also increase reaction rate. All right, so here is a quick activity we can do on changing. It's called Changing with the Times. It's in the textbook, page 154 in the textbook. And basically, it is predicting, looking at this chart, and there's two different trials for each chemical reaction, predicting which reaction would go faster. So we're not performing the reactions. We are just going to read the description of each trial, and then we're going to think about the effect of the change in conditions on the rate of each reaction. All right, so this slide is just going over the answers from the Find Out activity on page 154. So if you want to go over the answers, you can just pause the video there. We've already gone over them in class. Okay, next we're going to talk about catalysts. So speeding up reactions with catalysts. So a catalyst, it's a substance that can speed up the rate of a reaction without being changed itself. So basically, it could be added to a reaction. It won't affect the amount of product produced in a chemical reaction. All it's going to do is increase the speed of the reaction, all right? It's not going to do anything else to the reaction. Enzymes are natural catalysts that are made by living things. So for example, our saliva contains an enzyme. You may have learned this in grade 8. Our saliva contains an enzyme called amylase, which starts to break down the starchy food that we're eating, and it'll start the breakdown of it in our mouth. We also have enzymes in our tears, which attack cell walls of bacteria, which prevents infections in the eye. So enzymes are natural catalysts. Catalysts are substances that speed up the rate of a reaction without being changed itself. Okay, we're just going to watch these videos here on chemical reactions. All right, so our next slide we're looking at, we're slowing down reactions with inhibitors. So inhibitors, these are substances that are going to slow down chemical reactions. So for example, some plants, they have natural inhibitors in their seeds, which prevent germination until conditions are favorable. So that's how seeds are able to go into that dormant stage. Inhibitors are also added to some foods and medicines to slow down their decomposition. So for example, hydrogen peroxide. Hydrogen peroxide is used to disinfect wounds, but it decomposes very quickly. So inhibitors are added to bottles of hydrogen peroxide to prevent the decomposition from happening too quickly, resulting in the formation of just oxygen and water. All right, next we're going to talk about some specific reactions. The first one we're going to talk about is corrosion, a corrosion reaction. So this is the oxidation of metals or rocks in the presence of air and moisture. So for example, rust. Rust is a type of corrosion. So rust is basically iron oxide, shown here, which is a product of the chemical reaction of iron, oxygen, and moisture. Right, so this here is the reaction. We have iron and oxygen reacting to produce iron oxide. Iron oxide is rust. But what happens is corroded material lose their strength. So there is this process called galvanization. This process protects metals. So basically you can coat them with a thin layer of zinc. Zinc is used because it's more resistant to corrosion. Some car bumpers are coated with a thin layer of chromium, which will also protect the iron from corroding. Okay, so here we're just looking at two buckets here. The bucket on the left has been galvanized, so therefore we don't see the rust, versus this bucket here on the right, which was not galvanized. So therefore it's very, very rusty. All right, so we'll just watch this quick video here on corrosion. All right, so the next type of reaction we're going to talk about is the combustion reaction. So this is a highly exothermic combination of a substance with oxygen. It requires heat, oxygen, and fuel. Examples are burning in a fireplace, a gas barbecue, furnaces in the homes. Internal combustion engine in a car also uses combustion. So the gasoline combines with oxygen to release energy to make the car move. Food that is eaten is also converted to energy by combining with the oxygen that we breathe in. However, products of combustion are not always beneficial. So for example, smoke, ash, soot, carbon monoxide, carbon dioxide, and other pollutants. Smog is another example. This is the brown haze that hangs over some cities. And what happens is sunlight is reacting with pollutant chemicals produced by burning fuels to produce that smog, that brown haze. Right, this is a chemical reaction here at the bottom showing propane being burned in a barbecue. So propane plus oxygen, it produces carbon dioxide, water, and energy in the form of heat. And here is a reaction showing methane in natural gas being burned in a furnace. So methane, the CH4 gas, plus oxygen produces carbon dioxide, water, and energy as heat. I do have a video on combustion. Just going to pause it here. All right, so our last reaction we're talking about is cellular respiration. Cellular respiration, it's a chemical reaction that takes place in the cells of the body when the food or the glucose, it reacts with oxygen to produce energy. It's also producing water and carbon dioxide. All right, so if we look at this word equation, we have food in the form of glucose plus oxygen. Notice oxygen is shown as O2 because it's diatomic, and it's producing carbon dioxide, water, as well as the energy that we use, that all living things will use for all our day-to-day actions, anything that we do to survive, our movement, all our body processes, and so on. Alright, so I have one last video to show on cellular respiration.